Okay, folks, let's get started. Welcome to Native Feature with Xamarin.Forms. I'm Chris Miller. I'm a software architect for Tyler Technologies. You can find me at all the usual social places. I won't spend too much time on this slide because it's being recorded. You can always come back and see it. Our company is hiring, by the way. We're all over the country, and of course, right now, pandemic, everything's work from home. Please email me at chris.miller@tylertech.com if you have any questions about a position at Tyler. So, shameless plug time. I am a Pluralsight author, and the session you're seeing today is an abbreviated version of my latest one, which is working with native features in Xamarin.Forms. So if you like this session and you want to go a little deeper, hop over to Pluralsight and take a look at it. So, what are native features in terms of what we're going to be talking about today? Well, we have hardware-specific features like the camera, the keyboard, sensors like GPS, barometer, temperature, and so forth. Or it could be an external device that you've hooked up either directly through USB over, USB or Bluetooth. And then we have operating specific, OS specific features like the photo gallery, because every platform has one. They're all slightly different, but they all do roughly the same thing. And then there's messaging, SMS, iMessage, and so forth. Email, all the mobile platforms have a way of sending email, sometimes multiple ways of doing it. And permissions, because sometimes you need, well, not sometimes, but a lot of time you need permission to access a particular feature, like with maps is a great example of needing permissions and other things to be set. And their device metrics. There's platform and idiom. So platform is pretty obvious. Are you running on iOS? Are you running on Windows? Are you running on Linux? Idiom, it's a little more abstract. It's basically what the form factor is. Are you running on a tablet? Are you running on a phone? Is it a desktop? Or is it even a watch? All this information is considered like a native feature. So how do you get access to native features? Well, Xamarin.Forms, you get most of what you need out of the box, but sometimes you need to go a little bit deeper. So let's talk a little bit about Xamarin Essentials. It's the first thing to check when you need to go native features. New projects get it by default, and it is a part of Xamarin and is fully supported. And it's not Xamarin.Forms specific. You can use it with native Xamarin applications. Here's a quick tip. Check Xamarin Essentials first whenever you need to get access to a native feature. Don't invent the wheel if someone else has already done it for you. Here's a little bit of an origin story for Xamarin Essentials. It started out as a set of plugins by James Montemagno. Very popular, always open source, and a lot of people were contributing to it. And it was very handy. In fact, we'll be using one of the plugins today. Over time, it became Xamarin Essentials. They reworked the API, so you now have a consistent API across all the different parts of Xamarin Essentials. Lots and lots more features, and it's constantly being added to. It's now an official part of Xamarin, which means it's fully supported. So whenever there's a new update for Xamarin and it requires a change to Xamarin Essentials, it will be released at the same time. And it's still open source. It's on GitHub. You can look at the source code, you can report issues, and you can even contribute back to it, which is really cool. So what comes with Xamarin Essentials? So many things. I made this slide a few months ago. I'm sure there's a lot more stuff added to it since then, but so many of the things that each platform does, but does slightly different, you can find in here, which is really cool. So how do you use Xamarin Essentials? Well, if you have a new project, you're getting it out of the box already. But for older projects, you just need to add the NuGet package, Xamarin Essentials. It's pretty easy. Install package, Xamarin Essentials. Then you add the platform setup code and permissions. This is mainly an Android specific feature where you just call Xamarin Essentials.platform.init and you pass in the bundle. And then you add the platform setup code, the permissions, which is also handed for you automatically when you add Essentials to it. So this is just boilerplate code. Usually never have to see it once it's done. And then you just add a reference to Xamarin Essentials to any class that actually makes an API call using Xamarin Essentials. And then you just call the API when you need it. So in this case, Browser.openAsync is a Xamarin Essentials call that will open up the native web browser on the platform. So you don't need to know, is it Safari, is it Chrome, is it something else that the user's installed and made default? No, browser OpenSync will handle that for you. So let's do a quick demo of Xamarin Essentials. And I've created a little app already. It's loosely based on one of the Xamarin templates, and one of the pages is a map. And what we're going to do is add some additional functionality to that map. So let me go into my notes. So what we're going to do is add the ability to do some geocoding. So first thing I'm going to do is I'm going to add some new properties. And what we'll do is we'll go into our view model. We're going to add an address. And we're going to add a location property. And then I'm going to add a command that will get called geocode. And we're going to say down here, geocode command is a new command, async, and our locations equals, wait, geocoding, if I spell it correctly, if I get the case correctly, and since it's part of Xamarin Essentials, let's pull in Xamarin Essentials so we'll get our IntelliSense. Now we can say get locations async from the address, is what the user will be typing in. And what we're going to do is we're going to take the first location returned, because when you're doing geolocation, you could get multiple hits back for your location. We want first or default, and come on, whoop, whoop, first or default, not first of default. Sorry, we get for not copying pasting everything. Yeah, come on. And then we will do, why are we not picking up link? No, show potential fixes, Xamarin.Forms. Why are we not picking you up? All right. I know we need system link. And using those dot input. And if we have a location that's not null, we're going to set location to a string that will show the lat long. We're going to have the latitude and the longitude. And then we will create a map position of that latitude and longitude. And then we'll tell the map to move to that position. Now that we have that, let's add this to our view. And I should still have that open. Nope. So let's add an entry field for our address. We're going to bind it to the address field we created. Let's add a label to show our Latin long. We'll just center that. And then we'll just add a little button. It'll do the geocoding on the address. And if I've created that correctly, it should compile and run. We'll start with Android. And there'll be a brief pause while Xamarin compiles my application. The cool thing is that when you're watching the Pluralsight version of this, that I get to skip over the slow parts of the code compiling. And let's see. Hurry up, little linker. You can do it. What? What? What did I get wrong? Oh, yes. Sorry. We are missing just a parentheses. And I'll that sucker again. Yay, we're deploying to my emulator. Here we go. So on our map page, wait for the map to be initialized. So if we were to type an address here, so let's just say Las Vegas, and then click geocode. It did the lat, got the long, and went right to it. So it's pretty cool. So this is using the geocoder that comes with the Google Maps. So if we were to type in, let's say, White House, it should go right to the White House. Empire State Building. And jump back and forth. So this is built into the Google Maps API, and Xamarin Essentials is giving you a nice wrapper for it. Apple Maps has an equivalent functionality, and let's just bring that sucker up. Actually, this took a little longer. We'll catch up on the iOS demo for the next demo, but it essentially be the same code. And while we're in here, here's where we're also using Xamarin Essentials. This, when you create a new Xamarin app using one of the templates, you'll get this out of the box. So you'll get Essentials, whether you whether you were expecting it or not. You get Essentials. And let's keep going. So now let's talk a little bit about the device class. This gives you device metrics. This gives you the platform and idiom checking. It gives it to you in XAML and C#. And it gives you some helper functions for doing some async and background coding. So let's talk about platform check. So for C#, you would check device.runtime platform. And that'll come back with Android, iOS, UWP or WPF, macOS, and there are others. There are community-supported implementations for Tizen and Linux as well. So in code, you just do a switch on device.runtime platform. So what we're going to do here is we're going to set an image based on what platform it's running on. So if it's running on iOS or UWP, we want our logo file to be logo.png. If it's Android, we're going to go with a vector drawing. So we're going to use logo.xml. And then for our image source, we just say image source from file, and we pick logo file. And that will pick the image from the platform. So to do it in XAML, you use on platform with on. So to do the same thing we did in C#, we have our image source, and then on platform, and then we have to set type argument to image source. On platform needs a type argument element, otherwise it will not know what it's sending back. So we just say on platform, so we say iOS UWP, our value is logo.png. If it's Android, it'll be logoa.xml. And there's also a shortcut way of doing that as well, where we can just say on platform, logo.png, that will be the default. So if it wasn't Android or iOS, it will use logo.png. Otherwise, it will use logo.xml or logo.i.png. So idiom check. So in C# we use device.idiom, and that will come back as desktop or phone or tablet, TV, or watch. This is important because if you're running on iOS, you can be running, even though it's called iPad OS, it will come up as iOS in Xamarin. So if you need to tell the difference between a phone and a tablet, you'd just use device.idiom. So in code, you can just check if device idiom is equal to target idiom.phone, then you can say, okay, I want my start page to be a phone page that's optimized for the layout of a phone. If it's a tablet, well, I can set up a page that will be specific to the layout of the tablets that I'm working with. And then you can do desktop, and then you can have errors if you don't find anything. But it's pretty straightforward to work with. And you can also check it in XAML, so you can use on idiom. So in this case, we're setting the column definition with setting grid. So we'll just say on idiom, you need to set type argument to grid length. And we're saying, so if it's tablet, it's 100. If it's phone, it's 50. And of course, nowadays we can do this much shorter. We can just say column definition, then width. On idiom 250, which would be the default value. If it's phone, it's 75. If it's tablet, it's 150. And of course, you get some background goodies with the device class. You get begin invoke on main thread, because if you're doing anything in the background and you need to update the UI, you never, ever want to do that from a background thread. Always do it from a foreground thread, or bad things will just happen. And then you have invoke on main thread async. And the big difference is begin invoke is basically set and forget. Invoke on main thread, you get back a task and you can wait for it. And you get device.timer, which makes it an easy way to have a platform independent way of setting a timer. So here's an example of how you could use that. So we're going to have a timer. It's set to go off after 90 seconds. And then it'll call device.begin invoke on main thread, and we'll do something with the UI. And then if you need the timer to keep going, you just say return true. If you set defaults, the timer ends. So now we can talk a little bit about dependency injection. This is the way to really do advanced stuff for having code that will be platform specific, and then you can have Android, iOS, Windows, and so forth implementations. So the way you do this is pretty common across all the dependency injection libraries. You define a shared interface, you implement your platform specific code, you inject that platform specific code at runtime, and there are multiple ways of implementing it. Out of the box of Xamarin.Forms, we get something called the Dependency Service class. It's part of Xamarin.Forms. It's a light form of dependency injection. There are a few things that are missing or are a little difficult to work with out of the box. It's really easy to implement. And it does have some limitations, like a default constructor and uh, the lifetime of the objects, all of which you can get at, but it's not readily exposed. So how would you use the dependency service class? You create an interface, you implement the interface for each platform, and then you register the implementation. This is usually done with the platform implementation. And then at runtime in the shared code, you resolve that implementation. So let's do a quick little demo of how to use the dependency service. So we're going to go back to our demo, and what we're going to do is we're going to add code to hide the keyboard after you've paused typing back on our map view. So I'm going to create a new folder, add folder, call it interfaces. And what we're going to do is define our interface. Whoops, a little blip. And I'm going to call this keyboard helper, or iKeyboard helper since it's an interface. Look. And we're going to say it's going to expose one method called hide keyboard. And now we can do is implement our platform specific versions. So let's start with Android. And we're just going to say add class. To make it less confusing, let's call it keyboard helper. Look, it implements iKeyboard helper. So first thing we're going to do is, come on, here you go, add our interfaces. And now we'll just define quick void hide keyboard. So to hide the keyboard in Android is pretty straightforward. What we do is get a reference to our input manager. And did I actually add, oh, this is where we need a plugin. Jumping ahead of myself, make sure I have that in there. No, I do not. So to get at the keyboard, we need to get the current activity, which isn't directly exposed in Xamarin.Forms, but there is a way to add a plugin that makes it really easy to work with. So we'll just add that real quickly. Browse, and that's plugin.current activity. And we install that. Bump, 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 bump. And we just need to add a line to our main activity. Init that, and of course, since we're referencing it, we need to using plugin current activity. Copy that because we'll be using that again. And then we go back in, and then in, where are we? So what are we missing? Yep, input methods. There we go. So input manager is not null. We can say input manager dot hide soft input from window. And because I'm lazy, I'm going to copy this guy. And big in this. Window. That's what I want. And then one more. Token, comma, new line. Hide soft input flags. None. So that really ugly code will hide the keyboard on command. Other thing that we need to do is bring in Xamarin.Forms. We need to register. And we do this with an assembly attribute. We say assembly, colon, dependency, type of, and the monkey demo droid keyboard helper. And so what this will do, it will register this implementation. Dependency Service uses something called the locator pattern to find the implementations at runtime. And if you create a dependency service implementation and for some reason it doesn't show up when you run the app, make sure you've done this step. This part I always leave out. I always go, why doesn't my code work? Because, well, I didn't include all the code. All right, so that takes care of Android. So let's do this for iOS. And we'll just add a new class. Keyboard helper, because be consistent. And of course, it's public. And it's also an implementation of my keyboard helper, so it needs to pull in our interfaces. And we'll do public void hide keyboard. And this is much simpler, so we're just going to say UI application, shared application, key window, and editing. True. That will hide the keyboard. And of course, we need to have our assembly attribute. And we need to bring in Xamarin.Forms. All right, so now we need to add the code that's going to trigger this. So we go back into our map view. It should be around here. And because I do not want to screw this up and I'm watching the time, I'm going to cut and paste a timer. So we have a timer. It's going to be called reset timer. And what it's going to do, once I bring in all the bits and pieces, after 2 seconds, it's going to use messaging center to say, hide the keyboard. And then it's going to reset it. And the way we trigger that is we go back up to our address field. Whenever the address is changed, we're going to call reset timer. And when reset timer fires, it's going to call messaging center. So now we need to put the code in the map view to recognize what to respond to the messaging center command. So we'll go back into the page and we'll wire this up in our on appearing event. So we're going to say subscribe a message from the map view model called hide keyboard. And it's going to say device begin invoking main thread, dependency service get, and I'll bring this guy in. Give me the implementation for iKeyboard helper. And if it's not null, call hide keyboard. And since we're doing this the right way, if you've wired up Messaging Center in on appearing, you need to unsubscribe from it in on disappearing. You know, you're basically subscribe, unsubscribe model. Now, this should work. Oh, come on. While waiting for this compile, we're looking at dependency service.get. If this fails, it's usually because you didn't have the dependency attribute. And the cool way, because we've written it this way, where we're checking for null, if you're on a platform that doesn't have implementation for it, that will come back with null and it won't call that method, which is really cool. That way you don't have to say, is this null? If it's not null, no, just use question dot. Come on. Okay, I see a question about how you can calculate distance if possible. That's a little beyond what we're going to do here because there's some little bit of math there because you need to, for doing distance, you can use an API method. It depends what platform you're doing. You can calculate with just lat and long if you use one of the equations that count for the curvature of the Earth. Yeah, it's slow. All right, let's go back to our map. So now if I just type something here and wait a couple seconds. Oh, you've made a fool out of me. Why are you not? What did I miss? What did I not hook up? That's what you're supposed to hide. Do we even get to this point? All right, we're getting there. Are we not getting that keyboard helper? Oh, we are getting there. You're getting that. That did work. Why did we not work? Did I get that wrong? Let's just take a quick peek at the version that I did earlier. Yeah, I apologize for the slow machine. I'm due for a new machine that'll hopefully compile these things a lot quicker. Let's see. And build started. Here we go. Hey, please work this time. It did work. Of course, I hit it by the debugger. So let's do it again. And the keyboard's gone. I obviously typed something that compiled but was not actually correct. All right. And so there, dependency service is just one of the different ways you can do dependency injection. There are other libraries out there. AutoFact, Inject, Prism has one. There's TinyLOC. Microsoft has an easy one to use. It's called Microsoft Extensions.Dependency Injection. This is Microsoft's own DI container. It's part of the core framework. It comes with the ASP.NET, but you can use it separately. You can install it via .NET CLI or NuGet. So you can do .NET add package, or you can do install package. So how to use it? Well, you create an interface. You implement the interface for each platform. And then you initialize the app service provider. And if you've done this in ASP.NET Core or Blazor, it's pretty much the same thing. Excuse me. And you inject the implementation at runtime. So let's go back and add one more piece to our demo, and we'll do it with the Microsoft library. So what we're going to do is we're going to add a new interface. And what we're going to do is after we hide the keyboard, we're just going to display a little toast type message. And add new item. And just to make sure that I'm doing this consistently. We're just going to call it toast message, which is, a common feature in Android and occasionally in iOS. And it's pretty simple. It's just going to have one method. Public. Why not? It's just going to have one method called show toast, and it's going to just display whatever that string is. The next thing we're going to do is we'll add the implementation for Android, which will be really trivial. Message.cs. And a public class that is an implementation of my toast message. So we just need to pull in our interfaces. And we're going to have our method, show toast, which is just going to call it Android toast, make toast with the application context, your text message, and how long it is. And I always forget the show part, which is why I cut and paste it, because just calling make toast just makes it toast. It doesn't actually pop it up on your screen. Now we'll do the iOS version, which will be a little trickier. And we'll call that message. Post message, so we bring in our interfaces. Thank you. All right, so first thing we're going to need is a view controller. And then our toast message is going to be a UI alert controller. So I'm going to need one of those. Now I can create my actual implementation for this. So the first thing we're going to do is get the top level view controller so we can fire off that alert window. So here's our UI view controller. I'm going to create an instance of an alert controller, and we're passing in our text, and we set our style to alert. And since Android toast messages look odd in iOS, we're going to add an OK button. And what we're going to do is we're going to create it, keep it up on the screen, and automatically destroy it. So to do that, we're going to create a thread. And then we'll do is give it a couple seconds. I like 3 seconds. Then from the main UI thread, we're going to close that view controller. And then our thread is done. We can say thread abort, and I'll dispose of it. Now we can, missing a few parentheses there. We can start our thread. Meanwhile, that thread is sitting there for 3 seconds. That gives us just enough time to present our view controller. And that's how you do a toast message in iOS. Now, this does not have the assembly attribute. We do something a little differently here. We're going to do some actual dependency injection. So we need to do is go into, the first thing I do is actually install my NuGet packages. So we'll go to Package Management Console. And since I want to install Microsoft Extensions Dependency Injection in all the projects, I'm just going to say git project-all and then pipe that into install package Microsoft Extensions Dependency Injection. And that'll take care of that for us while we're doing. So while that's busy, actually it should be all done. We go back up to our shared code and in appshell.xaml.cs, we're going to add static service provider reference. We need this to do our dependency injection. And we're going to add a new class called startup. Okay, so I already know I'm going to be using dependency injection, so let's first bring that in. And it's not, that's bad. It's not an interface, it is a class. So it is a public static class startup. And it is going to have a static method called init. Init is going to take a method being passed in from the platforms, and this is what is going to register our services. So what we're going to do is create a new instance of our service collection. And then we will call our native configure services method that was injected in from the platform specific code. And then create an instance of the app service provider. Boom. And then finally, what we need to do is in our where are we? We need to inject this at the platform. So in Android, it'll be in main activity. And we're just going to call, because it doesn't really matter where you do it, just as long as you do for load application, we're just going to say startup, init, and we're going to do a lambda. So add transient, so we need to add dependency injection. That should have been enough. Nope, gotta bring the interfaces in. So there are different scopes. So add transient means that every time that you call toast message, it's going to create a new instance of it. You can have, there are different scopes. You can, we did. You can add a singleton, so it'll create just one instance of it, and scoped, which is more of a web thing, because it'll create one for each web process. Um, Typically, you're going to use add singleton or add transient. And we'll do the same thing in iOS. If we do this in app delegate, and once again, we do it right before load application. And then we can have our code that will actually call it. So we go back to our map view. And we'll do, instead of calling dependency service, we do app.serviceProvider.get service of type I post message. And we say show post our message. My keyboard. You can see it works. It's nearly identical in terms of the mechanics of how it works for the dependency service. And we'll just fire this guy up. Once again, a brief or not so brief pause while we compile our application. Actually, if anyone has any questions, this is a good time for questions while we're waiting for it to compile. Here we go. And we're deploying. Hey, here we go. Why didn't I use threadful instead of creating a new one? For the purposes of this demo, I just went with something very simple. You could use a thread pull. There's no reason why you couldn't. So we'll go back here. We'll just type something random. Watch keyboard go away after a couple seconds. And then our by keyboard toast message pops right up. And that's all there is to it. So which one would you use? Dependency Service or Microsoft Extensions Dependency Injection? Dependency Service, it's the out-of-the-box experience. There's nothing extra to install. You get that with Xamarin.Forms. However, it is an easy install. You saw it's literally a NuGet package. Dependency Service is easy to use. Yeah, it wasn't much harder with dependency injection. And if you're doing anything in ASP.NET Core, if you're doing anything in Blazor, you're already using this. This is something very familiar to you. Dependency Service is a little less flexible. Dependency injection through the Microsoft extension is very flexible. And there's an expiration date on this. This is in Xamarin.Forms. It probably will not be in Maui. Microsoft Extensions dependency injection, it's not going anywhere. Your code is future-proof. So speaking of Maui, that was announced at Build this year. It's the next generation of Xamarin.Forms. And there's some breaking changes that will impact what we covered today. What is now known as Xamarin.Forms will be in the system.maui namespaces. Xamarin Essentials will still be there, except it'll be under system devices. And the dependency service at this time, and this could change, is not slated to come over. Maui is set to be beta at the end of this year as a preview release, with a general availability with .NET 6 a year from now. So where would you get help? The online documentation is really good. Microsoft has spent a lot of resources in the last couple of years, and their documentation is so much better, so much more consistent. So Essentials is in Xamarin Essentials. The device class is in Xamarin.Forms/platform/device. And the Microsoft dependency injection is in ASP.NET Core, Fundamentals, Dependency Injection. And the source code's all online. It's all on GitHub. You can see how they built it. You can log issues. If you want to add something, you can put in a pull request. And of course, there is always Stack Overflow. So that's it. Does anyone have any questions? Exactly. Dependency injection for the win. Oh, thank you very much. Like I said, this is an abbreviated version of a course I have on Pluralsight. So if you want to go in deeper and see more examples, you know, better demos, longer demos, because we're time boxed here. Cool. But we still have we have time for questions, so that's cool. I'm here for as long as you guys want me to be here, or until the next session starts. Oh, thank you very much, Pablo. External devices connectivity, limitations on Xamarin.Forms. Yeah, it's kind of rough. Because that's where you see the greatest differences on platforms. So it depends on how you're doing the external connectivity. If you're going over Bluetooth, that's probably where you have the most compatibility across platforms. Then at that point, you want to try to come up with a different API. Like what's a good example? Like a barcode reader. There are barcode readers that have Bluetooth, and they may have different APIs for both Android and iOS. And then you use Xamarin.Forms to do it. Other times, like I ported an Android serial port library over to Xamarin, and it works great for Android, but there's just no equivalent for iOS. So in that case, if you're doing a Xamarin.Forms app, you just wouldn't have that functionality on iOS. All right. So it looks like we're coming close to the end of the session. Like I said, if anyone has any more questions, the widgets edition of iOS, is it possible in Xamarin.Forms? I would say probably. I don't know. I'm not sure about Xamarin.Forms because you're at widgets are closer to the native platform. I don't see the benefit of doing it in Xamarin.Forms since all that code is going to be almost all native. You might have basically, if you were trying to share the code, I'd say you have native projects that called out to Xamarin.Forms. But if you're doing widgets, I don't see the benefit in doing it in Xamarin.Forms. Xamarin.Forms is one of the things it's doing. It's providing a container for all your UI, where the widgets has a completely different kind of container initialization. And as Jose is mentioning, widgets on Android, uh, that's a mixed bag of nuts. Because that's where you start seeing very platform specific limitations. You know, Google does one thing, Samsung does way too many different things to make it um, target. Oh, thank you. It was it's I've liked doing this session because it's been pretty cool, and it's something I do use in my own work. All right. Unless there's any last question, I think I'm gonna wrap it up here. Thank you all for attending, and I hope you enjoy the rest of your day here at MonkeyFest.